for the phase 2 of making an AI-powered cloud monitoring system. First, I used this website to download the CIC Malware Memory 2022 dataset. I ingested memory dump features, trained an isolation forest model, and visualized both anomaly clusters and feature importances. I pre-processed these dumps into a single CSV file, output 1.csv, where each row represents a dump's numeric features and a file name column that I drop before modeling. I applied standard scaler to zero center and unit scale each feature, which helps the model converge. Then, I used PCA to reduce dimensionality, keeping 95% of the variance. I configure the isolation forest with contamination equals 0.1, n_estimators equals 300, and max_samples equals 0.5, and fit it on the features. Here showing labels as -1 for anomalies, +1 for normal for each dump. Next, I run TSNE on the reduced features into 2D and plot them. Here, normal points appear in one color and anomalies in another. You can see clear groupings where the model isolates potential ransomware dumps. Then, I refit the isolation forest on the original scaled features. I compute anomaly scores with decision_function, and then treating these scores as pseudo-targets. This produces an importance ranking for each feature, helping us understand which memory artifacts the model deems most suspicious. As you can see, this produces an importance ranking for the top 15 features. Next, I plot the distribution of anomaly scores. Along the x-axis, we have the anomaly scores, where lower values indicate a higher likelihood of being anomalous. The y-axis shows how many samples fall into each score range. This plot visualizes the distribution of anomaly scores predicted by the isolation forest model. Most of the data points cluster toward higher anomaly scores as they are ahead of the red line. Hence, they are considered as normal. The red dashed line marks the 5th percentile threshold. However, you can see a tail stretching into the negative scores on the left side are classified as potential anomalies. This plot gives a clear separation between normal and suspicious behavior, allowing us to set a dynamic threshold based on the data's natural distribution. Any score below this threshold is flagged as anomalous. At this stage, I've built the core anomaly detection model, visualized clusters, identified key features, and set a threshold for anomalies. Next, I'll serialize this pipeline into an inference service, integrate it with time series metrics, and create live Grafana dashboards with real-time alerts.